Okay, and checking your values here, what I'm hoping that you've noticed in filling these in is that if you take your original x values, sorry, the original y coordinates, which are here, if you were to take those, which come from the x squared part of it, and then multiply it by the number that's in front, that a value, that's what's giving us our new y values each time. So if I look at the blue here and I compare it to here, I'm really timesing all of the y coordinates by 3 to get the new y coordinates. To go from here to the fourth one to part D, I'm really multiplying all the y values by a half, or taking a half of them. And similarly for the third one, or sorry, the fifth one, which is the 1/3, we're really multiplying all the y values by 1/3, or dividing by 3. So that's what I have written down here. We're multiplying the original y values by the value of a. Now that gives you your vertical stretch or compression, which changes your graph's width of opening. All right, so now we're going to use this information to help us actually graph our parabolas without having to do a table of values every time. Now this one, the y equals x squared, this guy has to be put right into your brain. This one always has a vertex at 0, 0. It opens up because it has a positive 1 as an a value. And then to get your y coordinate, the y is just equal to whatever your value of x is squared. So if you have a vertex at 0, 0, when you move out to positive 1 on the x, 1 comma something, or you move out in this direction from the vertex to negative 1 comma something, to get that matching y coordinate, you just take that x value and square it. So 1 squared is 1, and negative 1 squared is 1. So as we move out from the vertex 1 unit to the right or to the left, you should be going up 1 unit. And if we move out 2 units to positive 2, 2 squared, so we have y is equal to x squared, so 2 squared, or y squared, would equal 4. So when we move out 2 units from our vertex, we should be going up 4. Likewise in this direction, if we're moving out negative 2, negative 2 squared is still positive 4. So this is really what we need to know. When we move out 3 units to either the left or right, 3 squared is 9. So either left or right by 3 units, then we move up 9. And if we were to move out left or right 4 units from the vertex, 4 squared is 16. So that's what we're going to use to help us graph our graphs. Okay, our next slide. Let's do our original parabola, y equals x squared, and we have the vertex here at 0, 0. As I said, when I move out 1 to left or right, 1 squared is 1. I'm going to move up 1, out left or right. If I move out 2 units from the vertex, 2 squared is 4. I'm going to move up 4. Out 2 to the left, I'm still moving up 4. If I move out 3 units from my vertex, 3 squared is 9, I should be going up to positive, or up 9. Out 3 to the left, I should still be going up 9. So that's where we get our general opening of y equals x squared. Comes from that particular type of opening. All other, oh dear, that was really bad. Let me try that again. All other stretches and compressions are just going to be, that's still really bad, are just going to be multiples of those ones. Let me try one more time. They say third time's the charm, right? There we go, that is much better. So this is our y equals x squared. So when we go to graph our next one, the y equals 2x squared, all I'm going to do is figure out where the vertex is, which is 0, 0. It's still opening up, and when I go out 1, now normally I would go up 1 because 1 squared is 1, but this time I have to double how far I'm going up to stretch it vertically. Go out 1 to the left to go up twice as far as before. When I go out 2, I normally would go up 4, but I have to double that and go up 8. Out 2 and up 8. I feel like I've kind of, oh, I know what it is. I don't think I can see our axes here very well. Sorry, I'm just drawing that in because it's kind of messing with my brain right at the moment. There we go. That looks more. I was looking for my symmetry and then it was getting lost because I was looking at where my numbers were labeled instead. All right, and then if I went out 3 squared is 9, but then I'd have to double it. I'd actually have to go up to 18, which would be, you know, somewhere up here, which is kind of off the grid, but at least you get kind of an idea of which way we're going here. So that's our y equals 2x squared. And then when we go into y equals 3x squared, for every one I go out, when I go out 1 from the vertex, normally I go up 1, but I've got to triple that number. 3 times as high. When I go out 2, normally it's 4, but I've got to triple 4 to make 12. So it's just a way to do a quick sketch when you know your A value, your stretch factor or compression factor, and you know your vertex. All right, the next one I think I did in yellow, that was y equals 1/2 x squared. Vertex is still at 0, 0. When I go out 1, I only go up a half this time. Go up a half. When I go out 2 from the vertex, normally we would go up 4, but I'm only going half as much, so I'm only going up to 2. Out 3 would normally be 9, but I need to go half as much, which is 4.5. Out 4 would be 16, but then I only want to go half as much, which would be an 8. So I can actually put some more graph points on this one because it's a wider opening. When I go out 5, that 5 squared would be 25. Half of 25 would be 12.5. So 12.5 is here. And here we've got symmetry happening. Here's my 1/2 opening, and you can see that that is definitely opening wider. There we go. So I'm sorry for the mess on this. Hopefully yours is a bit neater than mine is. The last one was y equals 1/3 x squared. When you go out 1, you're only going up a third and a third each side. Out 2, normally you would go up 4, but we're going to go up 4/3. Cut the 4 into 3 equal pieces and go up there. So that's 4/3 is just 1 1/3. That's more like there. And then when I go out 3, that's normally up 9, but a third of 9 would be 3. So you can see this is definitely getting a little bit wider than our 1/2. 4 squared would be 16. 16/3 would be 5 1/3. 5 1/3 would be roughly here. 5 1/3. 25 divided by 3 would be 8 1/3. So 8 1/3. So this is something you should be able to reason through in your head and be able to graph without having to do a full table of values for it. Now, these ones are nice and simple because the vertex is at 0, 0, but actually they're all just this simple. It's just you're not always starting at the origin. So here's the key idea here. To graph a parabola from the vertex form, the only difference is that you need to graph where the vertex is. So that's your starting point. And then you use your value of A to decide if you're going to be moving up like we were in the above examples, or when you go out 1 or out 2, if you had a negative in front of any of your A values, that means you're going downwards instead of up. And then you follow what we just did in the example 3 above, where we were sketching them. When moving out in either direction from the vertex, consider the stretch or compression factor to decide how many up or down you need to go according to the explanation that I just gave up above. Okay, so make sure you've listened to this very carefully. I'd like you to practice now doing the graphs on the back. Your first step will be to plot where the vertex is, decide if it's going to open up or open down, and then from there go out 1, and then normally it's up 1, out 2, up 4, out 3, up 9, out 4, up 16. And I'm just getting those numbers by squaring how many I'm going out from my vertex, out on either side of the vertex, and then just take those values and times them by the stretch factor. Good luck.